Hey y'all, today we're going to talk about one special type of parallelogram, and those are rhombi, or singular, a rhombus. So a rhombus is a parallelogram. It's also a quadrilateral. It's got some special things, some special properties that make it a special type of parallelogram. So if we look at its sides, it has all the same properties of the sides that a parallelogram does. The opposite sides are equal and parallel, but what's new here is that the opposite sides of a rhombus, all the sides of a rhombus are equal. Sometimes people call it like a slanted square, because all the sides are the same. It doesn't have any special properties for its angles, but it does share the same properties as a regular parallelogram, and that is that the opposite angles are congruent and the consecutive angles are supplementary. Again, it shares the same properties of its diagonals as a parallelogram, but it has two special ones. The first one is that the diagonals bisect the angles of the rhombus. So if you look over here, this diagonal is cutting this angle from the rhombus into two equal smaller parts. Same thing over here. And you can see these four little angles are equal. Since the angles in the rhombus, the opposite angles are equal. This angle is getting cut into two smaller angles that are equal. This angle is getting cut into two smaller angles that are equal. And all four of these are the same. Another thing is that these diagonals are perpendicular. So you can see right here, they form right angles. So I end up with four little right triangles inside of this rhombus. So again, we can use these properties to write and solve equations. So if I know that this parallelogram is a rhombus, and I know that this angle in the middle where the diagonals meet is 8x plus 12, I can find x because I also know that this is a right angle. So I can write an equation that says 8x plus 12 is equal to 90. And then it's just a matter of solving an equation like we've been doing all year. So I get x to be 9.75. So it's just a matter of picking the appropriate property, using that property to write an equation, and then do some algebra. So again, I wrote that this 8x plus 12 was equal to 90 because these two diagonals make four 90-degree angles, so this angle must be 90. Here I have these two smaller angles, and these two smaller angles are formed by this diagonal bisecting this angle in the rhombus. So these two smaller angles are equal to each other. So I can say that they're equal. And then this is a matter of doing some algebra. So I subtract 2x from both sides, add 16 to both sides, divide both sides by 3, and get that x is 2. We'll do this one together, just like we did for parallelograms. This time I know that this side and this side, one's 10x minus 9, one's 6x minus 3. In a rhombus, all four sides are the same. So that means this 6x minus 3 should be equal to 10x minus 9. Subtract 6x from both sides, add 9 to both sides, and divide by 4, and get that x is equal to 1.5. So we're just applying the appropriate property to this situation. If we know about a rhombus's sides, we know that they're equal. So I've got two U-Dos for you to try. They both look like the problems we did about angles. So give those a try, and we'll talk about them in class.